Okay, so here we have our review for the chapter test. So let's go through this. So this is going to be test review. Number one, we want to put these equations from standard form, general form into vertex form. Remember, the textbook calls this standard form, which is not incorrect, but we're just going to call it vertex form. And so that looks like y is equal to a times x minus h squared plus k. So in order to do this, what we need to do is we need to do the process of completing the square. So if I look at that first one, a, I have f of x is equal to 2x squared minus 24x plus 5. So what I need to do is to factor out the leading coefficient from the first two terms. Notice it's not the greatest common factor, it's just the leading coefficient. And I leave a blank space in there. And so what I actually need to do is to add something. And so I take this negative 12, I divide it by 2 to get negative 6, and I square that to get a positive 36. Now because I added 36 inside of here, I need to subtract 2, the number on the outside, times that 36. And so I get that f of x is equal to 2 times x minus 6 squared. It's always going to be this number divided by 2. So this is a negative 12 divided by 2 is negative 6. Plus 5 minus 72 is going to be a minus 67. And so that is my final answer there. That is vertex form. So not too horrible. For part B, question B, we have that f of x is equal to 3x squared plus 24x minus 3. So yet again, what we want to do is we want to factor out the leading coefficient, which is a 3. So we're going to have 3 times parentheses x squared plus 24x divided by 3 is 8x plus something minus 3 on the outside minus something. So if we added 8, we're going to divide this by 2 to get 4, square it to get 16, and because I have a 3 out here, I'm going to subtract 3 times 16. So we actually get f of x is equal to 3 times x plus 4 squared. 8 divided by 2 is 4. This is a minus 3, minus 48, so we're going to have minus 51. And that is our completed answer in vertex form. Let's level that out. I guess I can't get level. Oh well. I'll tell you what we'll do. Just going crazy here at the OCD. That's not a big problem. We're just going to drag this line across. Make it nice and even. Doesn't that look good? All right, so finally we're going to have part C, which is f of x is equal to 7x squared plus 14x minus 9. And so we factor out the greatest common, factor out the leading coefficient, not the greatest common factor. So that gives us x squared plus 2x. We're going to have a plus something, minus 9 minus something. So here, this is 2 divided by 2, which is 1. 1 squared is still 1. And we're going to subtract the 7 times 1. So we end up with f of x is equal to 7 times x plus 1 squared minus 9 minus 7 is minus 16. And so that is our final answer. So the process for completing the square is not too intensive, but it does leave some room for some simple mistakes if you're factoring out the wrong piece or squaring to get the wrong number. So just make sure that you understand the process and use it correctly. Next up, we have to fill out this chart. So what we want to do is we first want to find the x-intercepts. And we find the x-intercepts by making y 0. So 0 is equal to 2x to the third minus 4x squared minus 70x. We can actually factor out greatest common factor, which in this case is a 2x. And that leaves me with x squared minus 2x minus 35. That's a quadratic. That is also factorable. So I get x minus 7 times x plus 5. Okay, I set these factors equal to 0, so I get 2x equals 0, x minus 7 is equal to 0, and x plus 5 is equal to 0. So what that actually gives me, when x is 0, I get 0, 0, I get 7, 0, and I also get negative 5, 0. So 0, 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. These are my x-intercepts. To find my y-intercept, I have to make x 0. Well, if I look, 0 minus 0 minus 0, y would just be 0. And actually, I already have the origin as an x-intercept, but that's also a y-intercept as well, because that's the intersection of the x-axis and the y-axis. I notice that this has an odd degree and a positive leading coefficient. So that means as I go to the right, I'm going to go up, and as I go to the left, I'm going to go down. So now I just connect these points. Try not to make this too ugly. There we go. And that's all we need to do there. So really understand your end behavior, find your intercepts, and you're okay. You're done. For this next one, we want to do the same approach. So we want to find our x-intercepts by making y 0. So I get 0 is equal to x to the third minus 4x. 0, if I factor out a greatest common factor, I get x squared minus 4. And I can actually factor that down more so. So that's x plus 2, x minus 2. So yet again, I have 0, 0 as an x-intercept, which means that's also going to be a y-intercept. I'm going to have negative 2, 0, and also positive 2, 0. So I have 0, 0, positive 2, negative 2. Just as before, we have an odd degree with a positive leading coefficient. So as I go to the right, that goes up. As I go to the left, that goes down. And in between, just a little squiggle. We did lots of practice with these problems. We did lots of review with these types of problems. So if you need some more examples, there's plenty of worksheets still posted on my website and also in the textbook that you can check out to give you more practice. Answers should be up there, but if you do have any questions about them, let me know. Then we also want to look at synthetic division. So here for these 3 problems, we're just synthetically dividing. So for number 4, I'm going to put, if this is an x minus 2, it's going to be positive 2 on the outside. So I'm going to have a 64, a 56, a 14, a 40, a negative 22. Well, these are going to be some large numbers, but that's okay. So I bring down the 64, and then I do 64 times 2, which is 128. And then I do 128 plus 56, which is going to be 184. 184 times 2 from the outside is 368. 368 plus 14 is going to give me 382. 382 times the 2 on the outside is going to be 764. 764 plus 40 is going to be 804. And then if we multiply that by 2, we're going to get 1608. Finally, we have a negative value, so if we add that, we're going to get 1586. So what does this mean? Well, if we started out with an x to the fourth, we're going to have 64x to the third plus 184 x squared plus 382 I'm missing something here. X to the fourth, x third, x squared, x. So this is going to be x to the third, x squared. Oh, no, sorry. Just going crazy. This 382 will be x. 804 is the area code, but it's also right here going to be the constant. And this 1586 is going to be the remainder. So we write our remainder as 1586 over x minus 2. And that is our answer for number 4 here. Let's look at that number 5 next. So number 5, hopefully a little bit smaller one. So x plus 1 is a factor. So we're going to have a minus 1 on the outside. This is 4x to the third plus 1x squared plus 0x minus 6. We need that 0x. We need our placeholder. That's an x. 0x. Okay, so we bring down the 4, and then we multiply 4 times negative 1, which is a negative 4. We add that to 1, we get negative 3. Here we multiply, we get a positive 3. Add to the 0, we get 3. Multiply by a negative 1, and here we get a negative 9. So our answer is going to be 4x squared minus 3x plus 3. We could do a minus 9 over x plus 1, which was our divisor. And that was the answer there. And if we look at number 6 is going to be x plus 9, so it's a negative 9 on the outside. On the inside, we're going to have 6x to the fourth, negative 9x to the third, 21x squared, 108x, and 61. So if I bring down the 6, and then I can multiply, so that's going to be a negative 54. If I have the negative 54 plus a negative 9, that's going to be a negative 63. If I multiply the 63 times the 9, well, that's a negative 63 times a negative 9. That's going to give me a positive 567. If I add that to 21, that will be 588. Once I multiply that by negative 9, I'm going to get, hold yourself, negative 5,292. And when I add that to 108, I'm going to get negative 5,184. When I multiply that times the negative 9, I'm going to get 46,656. And when I add that to 61, I'm going to get 46,717. So my final answer is going to be 6x to the third minus 63x squared plus 588x minus 5,184 plus 46,717 divided by x plus 9. So we've got some rather large numbers there. I honestly don't think that on your test they're that big. But it's worth checking over everything. So if I go through this, I already did it, but here I can see this is going to be a negative 54. And then I add, multiply to get a positive, add, multiply. Yeah, so this all looks good. Scary, yes, but nothing too bad. Complex numbers. So as we are doing these, we're just going to combine the like terms. So this I can write as 2 plus 4, or blob, whatever you prefer. 2 plus 4 minus 3i plus 6i. So this gives us 6 plus 3i. And that's it. just combining the like terms, and we're done. Same with subtraction. So if I have 7 minus 10 minus 9i plus 2i, yes, it is a plus 2i because this negative sign distributes in. So we get a negative 3 minus 7i. The only thing we had to watch out there is distributing the negative, but again, combining the like terms, not horrible. Here we want to multiply, so we're going to be multiplying these binomials together. So if I multiply this out, I get 21 minus 18i plus 28i minus 24i squared. Now bear in mind that I squared is equal to negative 1. So when I combine my like terms here, I get 21 plus 10i plus 24, because this is negative 24 times negative 1. And that gives me 45 plus 10i. So make sure that you watch out for squaring an imaginary number, because that will give you negative 1. And we have that same approach here. For number 10, we're going to have 7 times 8, which is 56, minus 8i plus 21i minus 3i squared. We know that the I squared is going to be a negative 1. So 56 plus 13i plus 3, that's a negative 3 times a negative 1. So we get 59 plus 13i, and that is our answer. So we won't be going really into depth. We could do some really complicated stuff here, like dividing and rationalizing, or not rationalizing, but working with fractions and making fractions and denominators real numbers. We're not going to be doing any of that, just adding, subtracting, and multiplication. So just treat the I as you would any variable, and then if you get an I squared, change it to a negative 1. I think that was it for that, yeah. And then so for the next ones, find the real zeros. So this is more division, this is more synthetic division. So for number 11, what we want to do is we want to synthetically divide. So if 1, 0 is 2, we're going to divide that into 1x to the fourth, 0x to the third, 0x squared, 0x minus 81. So we get 1, that's going to be a 2, so plus 2. Well, we could factor that as it is. Right, because if I do this, 1, 2, 2, that's a 4. That's 4, that's 8. That's 8. We're going to have a remainder here. You know what? Don't synthetically divide this one, because we can factor this. This is a difference of 2 squares. So x to the fourth minus 81, we want to equal 0. So we factor this to x squared plus 9 times x squared minus 9. So x squared plus 9, we can factor to x plus 3 times x minus 3. And this stays x squared plus 9. So if we set this equal to 0, x squared plus 9 can't be 0. So it's going to be an imaginary 0. But we're only asking for the real zeros. So we're going to get x is equal to plus or minus 3, and also the 2 that was given. So we can get that just by factoring, no need to divide. The next one, yet again, we can just factor. So x to the fifth minus 16x, factor out that greatest common factor, and we get x to the fourth minus 16. So we get x times x squared plus 4 times x squared minus 4. That's a difference of 2 squares, so I get x squared plus 4 times x plus 2 times x minus 2. We set this all equal to 0. So we do get x is equal to 0 and plus or minus 2. Because x squared plus 4 can't be 0, that would give us another imaginary value. And finally for 13, if we set that equal to 0, so 2x squared plus 32x is equal to 0, we get 2x, and that's going to be x plus 16 is equal to 0, so we get x is equal to 0, negative 16, and negative 4. Where does that negative 4 come from? Well, that comes from what was given. Okay. We just want to fill out the chart for these. No graphing required. First thing I could do is I could find my horizontal asymptote. The degree in the numerator and denominator are the same. So that means that I divide the leading coefficients. So y is equal to 9 for my horizontal asymptote. Holes I find by factoring. There are no factors here that are going to cancel out, so there are no holes. The X-intercepts I get by making the remaining factors in the numerator equal to 0. So 9x is equal to 0, so x is equal to 0. So my X-intercept is 0, 0. Y-intercept. Y-intercept I get by making x 0, so I get 0 for negative 9, which is 0. So see how these are the same? Origin is both an x-intercept and a y-intercept. And then the vertical asymptote I set by making the denominator equal to 0. So x minus 9 is equal to 0. So I get x equals 9. And that's it. For number 15, there is some factoring to do. So first off, I can find the horizontal asymptote by looking at my rules. Because the degree in my denominator is larger than my numerator, I get that a horizontal asymptote is at y equals 0. When that happens, I'm not going to have any x-intercepts. So I'm done with that part. Real quick, I can find my y-intercept right away. I can make x 0. So if I make x 0, I get 5 over negative 25. That's negative 1/5. So negative 1/5 would be my y-intercept. Now if I factor this, I get x plus 5 in my numerator. The denominator is a difference of 2 squares, so that's x plus 5 times x minus 5. If I reduce that, the x plus 5's cancel. So they actually, they give me the whole. So the whole is going to be x plus 5 is equal to 0, which tells me that x is equal to negative 5. The vertical asymptote is the remaining factor in the denominator. So x minus 5 is equal to 0. So that tells me that x is equal to 5. So it's a nice process. If you find that horizontal asymptote first, and then factor, anything remaining in the numerator is going to give you an x-intercept. Here, once you remain the 1, once you have that 1 left over, no value of x is going to make that 0. So that's another reason we have no x-intercepts. And then the denominator is going to be the vertical asymptote. So that's what we have for those. And that's the end of the review. So check out these answers. Make sure you go over your quiz as well, and let me know if you have questions.